Here we are with section 1.5, okay, dealing with volumes of pyramids and cones now. So we've looked at pyramids and we've looked at cones, and what we've been finding is surface area. So you look at a pyramid like this, the surface area, right, is the area of all the outside faces. We can unwrap it. You get what we call a net, okay, where you find the area of all the sides, add them up, and that is the surface area. That is a two-dimensional measurement, length and width, or base and height. Okay, divided by 2. So they are two-dimensional measurements. 2 dimensions. So a volume deals with 3 dimensions. You have a length, you have a width, and then you also have a height. Okay, so the volume deals with how much fits inside an object. Okay, if you look at the container like this has got some liquid on the inside. The surface area is the area of the top, the bottom, and the side around the outside. If you laid it out flat, it would be a two-dimensional measurement. If you're looking at how much fits inside, that has the area of the base, and then the height as well. So there's 3 dimensions. It's a 3D thing. We live in a 3D world, okay? So when we deal with volumes, it's how much we actually consume even. So you think about the liquid in a can, a 12 ounce of steak, you know, how much volume does that fill up your belly with? The amount of gas that we put in our car is measured in liters or gallons, okay? So these are 3D measurements, okay? And for all purposes right now, we're going to think of maybe liters, which is metric, and gallons, which is imperial, okay? And we can do some conversions between those measurements as well, okay? So we are looking at volumes. I'm going to show you a couple pictures here. Here we go. So some of you might recognize this as a box, right? And the box has a volume in it. We are not looking at boxes, but we are looking at what we call pyramids. You might be able to see the relationship between, say, this pyramid and this rectangular prism, they call it, okay? I'm going to put a center up top here, and we're going to draw a pyramid. Now you can see that this pyramid has some of the same dimensions as that rectangular pyramid, right? Or the rectangular prism. So the volume of this box would be length times width times height. So volume of a box is length times width times height. Okay? Now this pyramid on the inside is obviously less than that. Well, how much less would be the question. If you looked at it a little bit and analyzed it, cut it out of blocks, you might be able to fit a few pieces together. And let's take a guess, is there half as much volume in the pyramid as in the box? Is there a quarter? Is there a third? It just so happens, ladies and gentlemen, that it's a third of the length times the width times the height. And another way to write that is length times width times height divided by 3, okay? That is simply the volume of a pyramid. And in order to find the volume of a pyramid, all you need to do is use that formula, okay? Similarly here with a cone, put a point on the top, what they call the apex, and I'll draw the 2 edges. So you can see that the cone fits inside the cylinder, right? So the volume of a cylinder, if you can remember, is equal to the area of the base, which is pi r squared times the height, right? So pi r squared times the height would be the cylinder. Now what do you think the volume would be of a cone? Think about the pyramid, think about the box. What's the relationship? Just so happens that it's pretty much identical. It's a third of your pi r squared h. And another way to write that would be pi r squared h over 3. Okay, so these, ladies and gentlemen, are the formulas that you need to know, okay, in order to find the volumes of pyramids and cones. Now what we're going to look at is a couple different types of questions, okay? First of all, if I gave you a pyramid, right, that had all the dimensions, you'd be able to do it no problem. But how about if I gave you a pyramid that had, say, the side here, which could be 12, okay, and I'll give you the slant height here, which is, just give me a sec here, let's call that 25. Okay, at this point you're going to have to see that you have a right angled triangle. What you do is you take that triangle out you can see that the base here of the triangle is half of 12, so 6. This height is something that you don't know, we'll call it x, and we have 25. If you want to find the height, okay, actually let's call it h, so it makes it a little more